Hello and welcome. This is Marwan Omar, and my presentation is titled The Art and Science of Mobile Forensics. So let's get started. The topics for today: mobile forensics fundamentals and the process, acquisition and duplication, hashing and write protection, analyzing and investigating deleted data, and analyzing a malicious file. So what is mobile forensics? Mobile forensics is an electronic discovery technique used to determine and reveal technical criminal evidence. Mobile forensics involves the collection, what needs to be investigated, preservation, analysis, documentation, presentation of computer evidence stored on a computer. Here are the formal steps or parts of the process for mobile forensic investigation. We start with identification, identify the purpose of investigation, identify the resources required, and then preserve. Data is isolated, secure, and preserved. And then we move on to the analysis, identify tool and techniques to use, process the data, and interpret analysis results. And then documentation, which is the documentation of the crime scene along with photographing, selecting, and crime scene mapping, sketching and crime scene mapping, and then finally presentation, the process of summarization and explanation of conclusions is done with the help to gather facts. The goals of mobile forensics: finding legal evidence in computing devices and preserving its integrity in a way that is deemed admissible in a court of law. Preserving and recovering evidence following court-accepted technical procedures, and also identifying data leaks within an organization, accessing possible damage occurring during a data breach. Why mobile forensics? Using mobiles for money we all use mobile phones for money transactions. Growth of mobile use, as you can see here, is expected to grow up. So the number of malwares targeting mobile devices tripled in 2015 in comparison with 2014. Among all the malwares, ransomware malware capable of obtaining unlimited rights on an infected device and data stealers proved to be most dangerous threat in 2015. 2016 is likely to see, of course, it already saw an increase in the complexity of malware and its modification, and more geography is targeted. Threats targeting mobile devices: web and network-based attacks, malware attacks, social engineering attacks, resource abuse, data loss, and data integrity threats. Mobile hardware and forensics. Mobile forensics highly dependent on the underlying hardware of the mobile device. Investigators need to take different approaches for mobile forensics depending upon the mobile hardware architecture, whether it's for iPhone versus Android, etc. Knowledge of mobile hardware also become important in case of broken device. Mobile OS and forensics. A mobile operating system determines the function and features available on mobile devices and manages the communication between the mobile device and other compatible devices. This diversity in mobile OS architecture may impact forensic analysis process. Investigators require knowledge of the underlying OS, architecture, and file system of mobile device under the investigation. Knowledge of mobile OS booting process helps investigator to gain lower level access. Here's a diagram that shows us the architectural layer of mobile device environment. So we have the client application. Underneath that, we have a layer of APIs, communication APIs like SMS, email, etc. GUI API, phone API, middleware components, And then underneath that, we have the operating system layer. Underneath that, we have the device hardware consisting of display device, keypad, RAM, flash, embedded process, and media process, radio interface, gateway, network interface, and finally the network. Here's a diagram that shows the Android architecture stack. So we have the application layer, so user-defined standard applications. We have the home screen, contacts, phone, browser, etc. Underneath that, we have the application framework, which consists of the activity manager, and the package manager. We also have the telephony manager, window manager, etc. So these are support application API interfaces. Then we have the libraries, Surface Manager, Media Framework, SQLite, SQS, 5GL, OpenGL, etc. And so native libraries written in C or C++, responsible for handling different types of data. Custom-built virtual machines, and it's all based on Linux. So you have the Linux kernel, display driver, keypad driver, camera driver, audio driver, power management, etc. Built on top of the Linux 2.6 kernel responsible for interacting with the hardware. So this layer interacts with the hardware layer. Here's the Android boot process. As you can see here, the Android Linux kernel component first calls the initialization process. Then the initialization process accesses various processes and daemons, including init.rc, mostly known as zygot. Zygot is started. The zygot process loads the core Java classes and performs the initial processing steps. After the initial load process, zygot idles on a socket and waits for further requests. So this is the boot process for Android phones. We're looking now at the architecture of the iOS phone. iPhone OS stack consists of 4 abstraction layers. So we have the Cocoa Touch, MapKit, IAD, GameKit, Advanced, View Controllers, and UKit. Provides frameworks for iPhone app development. And then we have the Media Services layer, which provide audio, video, animation, and graphics capabilities to the phone. Core audio, core animation, AirPlay, JPEG, Playback, etc. Then we have the core services layer, which provides foundation to the upper layers, threading, file access, preferences, collections, and high-level features, iCloud, in-app purchase, and SQLite. Finally, we have the core OS layer, which provides low-level services, such as security firmware, accelerate firmware, external accessory firmware, etc. And it directly interacts with iPhone hardware. So this is the architecture of the iOS phone. Now we're looking at the iOS boot process. The iPhone boot process consists of multiple boot stages. Each stage verifies the integrity and authenticity of the next stage. The normal booting process uses a built-in chain of trust mechanism that prevents lower-level access to iOS implementation layers. Then we have the device firmware upgrade, or DFU mode, is used during a forensic investigation to gain lower-level access to the device. Using this mode, the investigator can alter the boot sequence. Normal versus DFU mode booting. Normal boot process, we have the boot ROM starts the booting process. LLB, the first level bootloader, is loaded after verification of integrity and authenticity. The stage 2 bootloader iBoot starts after verification of integrity and authenticity. And then the kernel and NAND flash is also loaded after verification of integrity and authenticity. For the DFU mode, iBoot is not booted during the DFU mode boot sequence. So we have the boot ROM, IBSS, IBEC, and the kernel RAM disk plus RAM disk. Booting iPhone in D mode, DFU mode. Connect the iPhone to a computer and launch iTunes. Turn the iTunes off. Hold down the sleep power button and home button together for exactly 10 seconds. And then you can release the power button. Continue to hold down the home button until a message appears in iTunes saying the iTunes has detected an iPhone in recovery mode. Mobile storage and evidence location. We have the internal memory, which is RAM, ROM, or flash memory, NAND, or NOR, which is used to store mobile phones OS, applications, and data. So the OS, applications, and data, they're all stored on the internal memory, which is the RAM or ROM or NAND or NOR. Then you have the SIM card. Stores personal information, address books, messages, and service-related information. Then we have the external memory, storage for storing personal information such as audio, video, image, files, etc. So these are the three different locations for evidence. What should you do before investigation? You have to build a forensic workstation, build the forensic team, review policies and laws, notify decision makers and acquire authorization, do a risk assessment, and build a mobile forensic toolkit. Building a mobile forensic workstation. Build a mobile forensic workstation with the following equipment: a laptop or desktop computer, USB drive, mobile hardware toolkit, Protect toolkit, mobile forensic toolkit, and then cables including the FireWire, Bluetooth, and IR, micro SD memory card reader, and SIM card reader. So these are the steps you need to take to build a mobile forensic workstation. Build the investigation team. The investigation team should consist of persons who possess expertise in responding to seizing, collecting, and reporting evidence from mobile devices. Each team member should have in-depth knowledge of a variety of mobile devices, their hardware architecture, operating systems, and mobile apps. Each team member should be aware of local laws and legal issues associated with mobile-related crime. Every team member should have the necessary clearance and authorization to conduct assigned tasks. Keep the investigation team as small as possible to ensure confidentiality. Identify team members and assign responsibility to each team member. Assign one team member as the technical lead for the investigation. Review policies and laws. Review local laws that may influence the forensic investigation. Investigators must follow a legally accepted forensics investigation process and create documentation accordingly. Review internal bring your own device and information security policies of the organization carefully in cases of forensic investigation involving mobile phones issued by the organization. Mobile phone evidence analysis. We have the phone memory data, we have the SIM card data, we have the service provider data. All of it goes to the workstation, forensic workstation, to be processed, analyzed, and documented. And then finally, we generate a report. Collecting the evidence, we protect the integrity of traditional and electronic evidence, prevent unauthorized users from entering the scene and touching the evidence, collect all the electronic devices found at the crime scene, check whether the mobile device is connected to a computer, confirm the power state of the device by checking flashing light, collect non-electronic evidence such as written passwords, handwritten notes, and computer printouts. Document the scene. Document all the electronic devices found at the crime scene. Take photographs of all the evidence at the scene and write notes on what you have seen on the screen. Document the state of the device during seizure. Document any activity on the electronic devices found at the crime scene. Document the evidence on identification. Identify the brand, model, operating system, and the network service provider. It helps to choose an appropriate forensics tool for the data acquisition. Connection identification. Identify the types of connection used to connect to the forensic workstation. It may be a cable, infrared, or Bluetooth. This depends upon the phone, forensics tool, and the acquisition conditions. And then selecting the tools based on the mobile device model and the connection. You can select a mobile forensic tool or a smartphone forensic tool with the following capabilities. Usable, it has to be usable. It has to be comprehensive, accurate, deterministic, and verifiable. Evidence preservation. The aim of the preservation step is to seize the suspect mobile phone and its associated peripherals without altering the data. It is the first step carried to prior to the actual investigation. It involves discovering, recognizing, documenting, and collecting the digital evidence obtained at the crime scene. Set for switching or on/off mobile phone. On state, if the device is on, do not turn it off. Turning it off could activate lockout feature. Write down all information on display, photograph or take pictures. If possible, power down prior to transport. Take any power supply cord present. If it's off, if the device is off, leave it off. Turning it on could alter evidence on device, same as computers. This is a Faraday bag used to protect the evidence during transport. Faraday bag. This is also another picture for a Faraday bag, where you can put the phone inside the Faraday bag to prevent interference with the evidence, tampering with the evidence. Forensic imaging. A forensic investigator should not directly work on the original evidence. He or she should instead create a forensic image of the mobile device obtained at the crime scene. File carving and forensic analysis is conducted on forensic image in order to leave the actual evidence intact. Possible mobile phone storage for imaging. Mobile phone memory, SD card memory, and the SIM card memory. These are the three artifacts that we're going to look for evidence. Duplication or cloning. FTK imager. We can use FTK imager as the primary tool for duplication or cloning of the evidence. Bypassing Android phone lock. Mobile forensic analysis worksheet. And the cyber attack mode, insider attacks, most dangerous external attacks. How are computers used in cyber crimes? A computing device is used as a weapon to commit a crime. Examples: launching denial of service attack, to sending ransomware, gaining unauthorized access. Forensic investigation types. We have public investigation. Public investigation involve law enforcement agencies and are conducted according to country or state law. Private corporate sector investigations. These are private investigations that are usually conducted by enterprise to investigate policy violations, litigation dispute, wrongful termination, or leaking of enterprise secrets. Digital evidence types. User-created data includes anything created by a user or a human. Using a digital device, it includes the following and more: text files, Microsoft Office documents, IM chat, bookmarks, spreadsheets, database, and any text stored in digital format. Audio and video files, digital images, webcam recordings, digital photos and videos, address book and calendar, hidden and encrypted files, previous backups, account details, email messages, and web pages. Such as social media accounts, cloud storage, and any online accounts created by the user. And this brings us to the end of our presentation. Thank you.